Welcome to the Digital AI Studio Platform Overview. In this walkthrough, we're going to kind of cover what the platform is, where things are, what the different areas mean, how do you use the platform effectively. We're not going to go into details about AI models and what that is and all the specific examples. This is just kind of an orientation for the platform and where to find things and how to do some of the basic things. What is Digital AI Studio? Well, it's a visual and interactive AI builder. Using the platform, you can build AI models, train them, use them for inference and just making predictions about things. The key is that it's all visual interactive. There's no programming required, and everything happens in the web browser. So it's easily accessible and easily usable by novice users. The platform is generally geared for students in STEM fields, either in high school or college, or frankly, anybody who's interested in learning about AI concepts and how to start doing experiments with AI models and building models and training models and using them effectively. So that's the purpose of the platform. So here's the landing page at www.digitalai.studio, and you might want to follow along. If you haven't gone there yet, you might want to do that now. If you don't have a free account, you can create one by just clicking Get Started, filling up your information, your email, password, and then create an account. But if you already have an account, you just push Sign In and type it in. And sign in. And here we are. So we're inside the platform, and by default, it puts us in the Welcome tab, which is what you're seeing right here. So this Welcome tab is basically an orientation page. It has some basic information about the platform, some suggested areas and where to get started, some links down here on how to get going with the platform. But in many cases, what's most important is here on the left are some models, either example models, like we see here. These are pre-canned, pre-built models that the platform supports. And this set of models is going to continue to grow in the platform. And if you want to load any of those and get started, you just click on any of those links. And if you have saved models that you have created, or an example model that you have modified, anything that you have saved is shown up here, and you can reload any of those at any time by clicking on those links right there. So at a high level, the platform is broken up into 3 tabs, as you see up here. Right now we're in the Welcome tab. There's a Workspace tab right here where most of the work will happen. It's an interactive desktop where you build and train and use your AI models. And then we have a Documentation tab, and we'll talk about this a little bit more in a bit. But it's a very comprehensive, full-featured, we try to document everything we can, including the examples and some suggested experiments that you can do. We'll get back to this in a moment. Let's go back to the Welcome tab. And the only other thing to note up here is the gear icon in the upper right. This is your settings menu. Of course, you can log out here by pushing log out. But typical platform, software information is your account, information about your account. You can change your password or delete your account if you want to, and some other preferences and those kinds of settings. Actual application settings, the kind of global settings, are found here. And, the version number and release notes can be found here. We don't have a lot of settings right now. There's a pro mode. We'll talk more about that in a bit. You can enable or disable that. And right now, every computation, everything you do, every training you do, everything you do is going to be running locally on your computer through the web browser. There's no backend server that it goes to for computation. Everything is running locally. In the future, we might support a remote server option, as an add-on, but currently everything is running locally on your computer, just to be aware of that. Additionally, there's a feedback dialog. If you have a bug or question or something goes wrong, or you just want to get some feedback on the platform, you can fill this out and send the message to us directly, or just use that, of course, that email up here at the top if you just want to send a normal email directly. So that's basically it for the settings menu. So let's move on to the most important tab, which is the Workspace tab, is where everything generally happens. And you see there's a grid in the background. Hopefully that's showing up good in the video. But to drag the workspace around, let me add a node just so you can actually see it. Just create something simple. There we go. So you can move the workspace around by just grabbing anywhere. If you grab on the node, you're manipulating the node, but just grab anywhere and move it around. You're dragging the workspace to zoom in and out. You can either use the mouse scroll wheel on your mouse or hold the shift key down while you're moving the left button up and down. So that's basically manipulations of the workspace. For the workspace itself, there's basically two areas of note. There's some command buttons here on the left, and we'll talk about those in a moment, and a console down here at the bottom. So various text information or results, things will be printed here. It is transient, so you'll see the text being printed and then it'll go away. This one line is not transient. It's always there at the top. What is your backend? Most likely it's going to be web GPU, which means that for AI operations and tensor operations, it's using your actual local GPU on your computer for those operations. And then currently the memory. We currently have 4 tensors in memory with this much data. And that's basically for this node here. There's 4 tensors associated with that node. But that's not super important. We'll get back to that later. So let me delete this guy. So these are nodes. We'll talk about that in a moment, but if you want to delete it, you just select it and push the X button. If you have nothing selected and you push the X button, then it'll delete everything after confirming it. But otherwise, if you just have a node, you can just, it'll just delete that one node if you push the X button. So that's the delete button. And if any of these, if you hover over them, as you can see, a tooltip comes up and shows you information about what each thing does. So let me delete these guys. And the first thing I want to talk about, okay, well, what is this? What's in here? How does this work? So Digital AI Studio uses a node graph. And I'm going to load an example graph here so we can talk about it a little bit more in detail. Let's just choose this one right here. So this is a node graph. And, this is a pre-canned one. So I should have mentioned that this is the add menu. So if you want to load a graph, either an example model, they're all listed here, and you can load those up. Currently, we have 5 example models, and we expect to be adding, a lot more in the future. But this is what we're starting out with. And save models. If you have saved a model of your own, you can load those up. They're listed here, and you can load those up directly by just clicking those buttons. So I loaded a model here. So this is a node graph. So what is a node graph? Well, it's a way of doing computations. So these are nodes, and you saw a little bit here. You can create them through the add menu, and there's many nodes, probably, 50, 80 is a lot of nodes, and we'll be adding more and more nodes in the future. This will be a continuing growing set, but you add them, they're categorized here, and you can add them. Let me add a simple node, and then you can place it wherever you want, but let me delete that since I don't really need it. So these are nodes, and you can grab them and move them around, and you want to keep your graphs nice and orderly, but you can grab them and move them around wherever you want. And so basically, what is a node? A node is a place of computation or an operation that's going to happen on data. Each node has inputs and outputs. Well, most of them have inputs and outputs. Inputs are these little ports you can see here. On the left or the top are inputs, you see here. On the right, like you see here, or on the bottom are outputs. A node may, or here we have some inputs that you can see here. We have some inputs that are not connected. There's nothing connected to. One of them has a connection, but these don't. So anyway, those are nodes. So data is going to kind of come into the inputs or internal data. Nodes have attributes. Attributes are like parameters or variables associated with each node, and each node has a type. Here we see 3 types here: tensor fill, tensor rand uniform, tensor arithmetic. So they each have a type and a name, or label, random features. You can change it. So but first I should mention, every time you select a node, and you might want to change some of its parameters, they're called attributes. The attribute editor comes up, which is you see here on the right. So the attribute editor appears as something is selected, and it allows you to edit the attributes associated with the node that's selected. So this node is selected, and here you can see here it reflects those values here in the attribute editor of the type of node, and the label, you can change it. You can see there the label updates, and that's for you to allow you to put a label on a node so you know what it is, what it's doing. It's for whatever purpose you want to use it for. You can give it a label like that. And every node has a set of attributes associated with it. And that's basically on the type of the node. That's the way the node is constructed. This node has 4 attributes: shape, min value, max value, and a seed value. And you can edit those in the attribute editor. I can change the max value to 5, okay? I can change the min value to -2. I can change the seed value if I wanted to. You can see there's a 4th attribute, shape, but I can't edit that one. Why can't I edit that one? That's because you can see here, it's connected to something else. So here I have an integer node here, which just has that one value 500, as you can see, and I could change that 520. Get rid of that guy. So this node has one attribute, 520, and it's sent to the output here, associated with that attribute, since it's right next to it, and that's connected here. So that node is connected to this node through this attribute right here. And you can remove connections by just grabbing them on the input and dropping them somewhere into the workspace. To create a connection, you grab the output of a node and drag the new connection where you want it to go. Drop it on top of the input where you want it to be connected to. Get rid of that guy. So like this is another node float. Value of 2 is being sent to that output and is connected to the input of this TensorFill mode here. Right there, so I can disconnect it by just dropping it off into empty space, and I can connect it by grabbing the output and dragging it and dropping it on top of the input where I want it to be connected to. So nodes and connections define the flow of data through the network. So through these outputs are data, different types of data. This is just a simple integer, float, as you can imagine. These bigger connections are full tensors. These basically this node takes in some integers and some other variables and outputs a tensor. So this node is actually creating a tensor. And that's sent through the output, which is connected to this guy, and that brings in 2 tensors and sends its data out to this one down here, and so forth. So basically data is flowing through the graph from node to node through the connections. And so the connections represent flow of data, and there's different types of data flowing through the network. They could be simple float variables, tensors. We're not seeing it here in this graph, but there's tables. There's all kinds of different types of data that can flow through the network. Usually thinner connections represent simple things like integers and floats. Some of these bigger connections represent more complex data, such as tensors. Tables will have a little bit thinner, different width for a table. Just kind of quickly show you what type of data is flowing through those connections. But it's fully dynamic. You can create and destroy these connections as you wish. So the nodes themselves are performing an operation, some kind of either a computation, creating data, doing some kind of operation or computation on the data that it has available. And that means their inputs. So like this tensor arithmetic node is bringing in 2 tensors, one from this node coming in here, one from this node coming in through the top. In this case, tensor arithmetic. So it's going to do a math operation on that node and send the result to its output here at the bottom, which goes to these other nodes. And they're going to do a different computation or operation and then based on its inputs and attributes, and then send their results to this node down here. All the way until, in this case, the end of the graph, which is basically these couple of nodes down here. So basically, the graph represents flow of data through the graph, and each node itself represents some kind of operation, transformation that is operating on that data. So let's go back to this quick example here. Like I said, when you select a node, its attributes are shown in the attribute editor. This one we cannot edit because its value is being overridden by what's coming in through this input through here. So you can see this node is outputting an integer with a value of 520. It was 500, but remember I edited it to change it to 520. So anyway, the actual number 520 is flowing through that connection and coming into this node here, overriding this value, which is the shape of the tensor is going to be created, which is a 1D tensor of shape 520, length 520, I should say. So that's why it can't be edited, because it's being overridden by this input. If I were to disconnect it, then yes, I can change the value 600. I can change that value. but since there was a connection there, its value is overridden and by the value coming from the input. So nodes, of course, can be selected, and the selected node, its attributes are shown in the attribute editor, as we just demonstrated. You can select multiple nodes. Maybe you want to move them together, move them around together, like we're doing there, or delete them all. If I push delete, those 3 nodes would be deleted. But basically, the selected node is shown in the attribute editor and allows you to change. There's enums, there's floats, there's all kinds of data that can be edited in the attribute editor. And if you see something in the attribute editor and it's disabled, you can't edit it. That basically means that something is overriding that value. You can see here there's 2 connections on this node, and those input connections are overriding the values of those 2 attributes. Finally, for the attribute editor, there's this icon here on the right. This is the information button, and when you push it, it switches to a quick overview document of what that node is and what it does. There's a more comprehensive document in the actual documentation tab, which we'll talk about in a little bit, but this is the basic information, quick documentation about the node, what it does, what each of the attributes mean. You can just easily get an overview of what that node does by clicking this information button and toggle back and forth. So that's a quick overview of the graph, node graphs, what it does, how information flows through the graph, how you can look at nodes, what the attributes are, and how you can edit those attributes in the attribute editor. And as I mentioned briefly before, to add, this is an example graph, so it's built for you. Remember, we loaded it from this menu up here. We loaded a graph. Let me load a different one just for fun. MNIST digits. This graph is built to recognize handwritten digits from an input image and give you a category result instead of a number. The previous graph was actually giving you a number, just a value, some float value. This graph is a categorization graph, and based on the input image, it'll tell you its best prediction of what that image represents. So the digit through, numbers 0 through 9. It's a very traditional, very classic example used in machine learning, and that's what this graph represents. But before we talk a little bit about that in more detail, let's kind of finish these action buttons here on the left. You remember the add. If you want to add a node, you can do that through here and place it automatically. And here if you want to delete those, I don't really want those nodes. You can delete them. Just select both of them, and then you push the X button, and both of them will be deleted. If I have nothing selected and I push the X button, the whole graph will be deleted. But of course, since you might not want to do that, maybe you push that button by mistake, you have to confirm if that's what you want. And let's say I modify the graph and I want to save my changes. That's this final button down here at the bottom. You can save your model. So you type the name of the model, some model, and an optional description if you want to remind yourself what this graph is, what it was for. You can give some optional description here. And then save. And when you do save it, it's not saved in a file on your desktop or anything like that. It's saved within the internal database of the web browser. So the model is always going to be there. You can log in next week or tomorrow. It's still going to be there, but it's only available if you use the same browser on the same computer. If you use a different browser or use a different computer, that model will not be there since it's saved as part of the database of the web browser itself. But if you did want to save your model to a file, if you're going to maybe transfer it to a different computer or give it to your friend or your teacher, you can push the download button, and then it would download the model into a file on your desktop, and then you can do what you want with it. So you have those 2 options. The other option is, it shows your existing models here, up here. I have 2 existing models, and if let's say you wanted to override one of them, you just want to maybe update one of them with your latest changes, you can just select it here, and then it fills in the name and description down here for you, and if you push save, it'll override that existing model. And as you can see, if I wanted to delete that model, I can just push delete there, and it would delete that existing model from the internal database. Okay, so that's saving your model. And you remember I said you can save the model to file. If you did want to reload that model, you'd be up here at the top and push the upload button here. So this is where you would reload that saved model back into the workspace that you might have saved to file. One other quick note before we proceed, you see all these green nodes around here. Those are special nodes. They don't do any computation, they don't have any inputs or outputs. Those are note nodes. If you, they're created here under add, annotation, note, if you want to create a new note node. And there it is, but I'll delete it, I don't need it. But those are just almost like sticky notes in your graph. This is the example graph, it's built for you, and we put note nodes throughout it, kind of explaining what each part of the graph does. And you can move them around and change the text within the attribute editor if you wanted to, but they're just kind of reminders telling you what that part of the graph does, or maybe to-do items, or maybe this is a homework assignment, you're going to give it to your teacher, so you can add note nodes to say what your thinking process was or why you did certain things. So they can be used for various documentation purposes right in your graph. Like I said, you can kind of think of them as sticky notes that you can place within your graph. One thing that makes them distinct from the other types of nodes, these other types of nodes, their color is fixed. It's part of the node definition itself. They have a fixed color, so you can easily identify them. But the note nodes, you can actually change the color through the color attribute within the attribute editor. Maybe the brick red, something, Warren, you gotta fix this, and something like that. So whatever you want to use the colors for, you can actually change the colors of these node nodes. Okay, one final thing I want to do is talk about this actual graph a little bit and what you can do with it. This isn't a detailed example description. We're not going to go into details about the AI model and how it works and all the bells and whistles of it. That'll be the topic of subsequent tutorials. But you just want to give you an overview of what this kind of graph is and what you can do with it and how you would train it. So if you remember, I loaded this graph. It's one of the examples. So example MNIST digits. So this is an MNIST database of handwritten digits. So this is a very classic example used in many AI courses and almost like a hello world of AI models, you could say. But it basically takes an image, and the model is going to predict, based on the image of a handwritten digit, what digit that is, 0 through 9. So let's start at the top of the graph. Usually the top or the left is where data comes into the graph, and usually be results, or the answers are at the bottom or the bottom right of the graph. So at the top we have an image drop node, which allows you to bring in your own image into the graph. You can either drag an image from your desktop and just drop it on that node, or as you can see here in the attribute editor, push upload, which allows you to upload an image. So here's some handwritten digits, and we have links where you can download this test data set if you want, but let's just load this 7 in, okay. So some of these nodes have data display windows associated with them. So what is a data display window? Well, you see one right here. This image drop node, when I download that image, it wants to show you that image. So it created this data display window and shows it on the workspace. So you're gonna grab them and move them around. If you're done with it, you can push the X and it'll go away. If you really want to, you can minimize it. Or if you want to download it, you can push the download button, and then you can save an image of that thing on your computer. Anyway, this image drop node created this window to show you what the image was that you downloaded. And you can see another one popped up here, category results. So this was created by this node here at the bottom of the graph. This is the final result, basically, what was predicted. So this category result node created this category result data display window and shows you the top predicted value through the AI network graph, which is 3. Of course, that's wrong. But this network is not trained, there's no trained data, there's no trained weights associated with it. So basically it's random right now. And you can see almost everything's around 10%. So it's basically garbage right now. This is just a random prediction since the network is not trained. And in this case, it thinks it's a 3. So of course that's wrong. Let's move back here at the top of the graph. So a very important node that should go on the beginning of the actual AI graph itself is the training switch node, and that does an important thing. During normal graph evaluation, it pulls the data from the top node. So in most situations, it's pulling the data from the top node and pushing it to its output, which the purple nodes are your actual AI graph. We'll talk about that in a moment. But since it's normal inference, normal graph evaluation here, it's pulling the input from the top. So that's why in this case, it pulled the image here. It gets, prepares the image, it manipulates it, just the scale and the range and everything and the size is proper. So this image got pushed into the graph, and then it, like I said, we went to this category result node here at the bottom, which made the prediction as a result of the evaluation through the graph. However, during training, it pulls the data in from the left input. During training, it gets the training data from its left input. In this case, there's various options here, and we're going to be adding more and more dataset options in the future, but right now, I loaded this MNIST dataset node, which you can find under here, data sources, image datasets. Right now, we have 1, 2, 3, 4 different dataset nodes. There's some table dataset nodes, and you bring in your own data through these user data nodes, but this is the MNIST dataset node, which brings in the MNIST training data. So that's all handled automatically for you behind the scenes. Right now, for training, you can see the first attribute is 6,000, so it's using 6,000 images for training, which is a small number. We want this trainer to go fast, but I think the maximum 60,000, so if we're in the want, I could change this to 60,000, and it would use 60,000 images when I train it. But by default, we'll just do 6,000, so it's a little quicker. And that's fine for the quick experimentation. Like I said, I don't remember exactly what's the maximum number, so how would I find that? Well, I can just push the information button here and look at it, num images, so how many training images. So here the max, 65,000. So you could increase that up to 65,000 images for training if you want. That's how you would find, more information about that attribute. Anyway, this input is only pulled through the graph during training. So underneath this training switch node is the actual AI graph. So those are special nodes called layer type nodes. It forms your AI model. This is your AI model itself. And I'm not going to go into details about this in a subsequent tutorial specifically about this example. We'll do that. But if you're familiar a little bit with AI concepts, we have convolution node, max pooling, second convolution node, second max pooling node. You flatten out the data with this flattened node here, and then a final dense node. And again, what is that? What is a dense node? Well, you can click here and find some information in the attribute editor about what that is. There's more comprehensive documentation over here, which we'll talk about in a moment in the documentation tab, but that's the quickest way to figure out what these nodes are. So you can see that dense node final units 10, it's going to be outputting 10 floats, and those are the prediction in 10 categories of our predicted number. So the purple ones are our actual AI graph. So at the bottom of the graph, connected to the output, are two nodes. One is the train node, which should be, if you want to train the network, you should have a train node connected to the bottom of the graph. So this is the one that controls training. It launches training. It has all of the training parameters, as you can see here in the attribute editor associated with training. But before I talk about this one, let's quickly talk about the category result node. We briefly mentioned it. It pulls from the output as well. So any output from the graph goes into the category result node. And basically, if anything new comes in, it's going to show you the predicted results. So I can reload an image and let me load a 4. Okay, so a 4, the image of 4 was pushed through the graph, hit the category result node, and it created this data display window. And again, since the graph isn't trained, it's just kind of random. I just picked a 3 at random because the network isn't trained. So let's quick train the network. So the train node has all of the training parameters, and this is a specific action that you launch. Training is an action that you need to launch from the train node. It has typical AI model training parameters. You select your optimizer, add in by default. What's your loss function? There's a bunch of choices, but this is a categorization example, so you choose that one. Your batch sizes here, number of epochs, test fraction. Actually, the MNIST dataset comes in with its own test dataset, so it's not using this variable, but if it didn't have its own test dataset, it would reserve a portion of the training data for validation. What's the metric to measure this by? Either classification or regression. This is a classification problem. Just for a little test, I'm going to reduce the number of epochs to 10. It's going to go very quickly. but let's just change it to 10. And remember, as we said before, when we train the network, it's going to happen, the computations are going to happen locally on your computer. Look down here at the back end, web GPU. So it's going to use your GPU for the actual training. So when I push the train button, it's going to train the network. Sees what's attached. It looks and sees what's attached to it, which is this AI network here. It's going to pull the data from the left here. Like I said, it'll pull the training data from this MNIST dataset node and train the network. What's going to happen when I push that button? It's basically going to, it doesn't want you to kind of mess with nodes or create connections or change attributes while training is happening. So it's basically going to lock up the display while training is happening. And there's a cancel training button, so if you want to kind of stop prematurely and cancel the training, you can do that, but the interface will be locked up while you're training. And also while we're training, there'll be the train node creates a data display window, which will appear here in the lower right, which shows our accuracy and validation curves while training is happening. So you'll see that pop up. So let's go ahead and do that. It'll probably take just a few seconds to train this simple network, but let's train it by pushing the train network button. And there it goes. You can see that training has started. You can see that the curves have started to progress through the 10 epochs that we told it to train. The two graphs at the top are, you can see here in the graph, those are our accuracy. So closer to the 1 is better. And there's two curves. The purple one is for the actual training data, and the lighter one is for the validation data. And the curves at the bottom are our loss. This is what the actual training, the actual optimizer is trying to optimize, trying to get this thing down to 0. And you can see it did a pretty good job. So the red is the loss for the training data, and the orange is the actual loss for the validation data. So you can see training has stopped by default since it's a classification example. It creates a confusion matrix for the validation data. So you can see if you look at confusion matrix, it did pretty well. Ideally, you want zeros in all these other side areas and a nice diagonal dominance right down the middle, but it did a pretty good job. And another thing to note is that it updated the graph, so it has a new prediction for us. So now it's a train graph, and it knows that this input image that we had 4 is a 4 with 93.7% confidence. I can go up here and change it to the beginning of the graph and change it to something else. Let's load our 7 again. Yep, it knows it's a 7. Load a 1. Yes, it knows that that's a 1. And 3. Yep, it's very confident that that's a 3. So it did a very good job as far as training the graph. I'm kind of looking to see if there's any miscategorized numbers here, but I'm not finding any. So anyway, it did a really good job of training. It's very confident that that these numbers are what we think they are, what they should be. One final thing to note is you can see that these layer type nodes, which form the AI network between the training switch and the train node, have changed. They now have this striped pattern on top of them. What does that mean? That means that these nodes have training data weights, internal weights associated with them. It's a trained network, so now it has internal weights, and that's what that is indicating, that those nodes have trained weights associated with them. If I go back here, let's say I want to retrain it from scratch again. If I train right now, it'll basically continue where I left off and continue to train the network even further based on the input training data. But if I didn't want to do that, I wanted to start from scratch, I can blow away, get rid of the training data by pushing reset network. When I do that, it'll go look at the attached network and reinitialize all the internal trained weights, kind of put them back to their random initial value. Yes, do that. Okay, so now you can see that they went back to their normal color, which means that there is no training data associated with them. And if you look at the predicted value, it doesn't know what it is. It went back to random value, so it doesn't know what this image is anymore. So that's a very quick overview of the workspace and a little bit how training works. Like I said, we're not going into detail about this graph or the example graphs. We'll be doing that in subsequent tutorials, which you can visit. But to move on, let's talk about the last tab, which is the documentation tab. So in here, you can find very comprehensive information about, what is Digital AI Studio, what are the concepts. What is, so we get the welcome tab, just kind of basic information about the platform and kind of a high-level orientation. You have concepts, what is a model? What is a graph? What is data? How is that used? Platform, what's the what is Digital AI Studio? What do the tabs mean? How is it laid out? Where is computation happening? How do the settings work? Okay, what is a node graph? What are the data types flowing through the graph? You can learn all that information here. Next is the workspace. What is the workspace? What does everything mean? What is a node? And what is a connection? And how do you create connections? What about data displays and files and things like that? That's all explained under there. Okay, for training, what does it mean to train? What is the training life cycle? And what data is involved with training? What are batches? What are the training parameters? Things like that can be found here under the training section. Okay, and next is notes. This is more of an API reference documentation. The structure here of the nodes kind of mirrors the add menu here in the workspace. So every node is documented, more detailed than, remember we have some quick help things like, what's convolution 2D, quick help there. So here's a quick help document about what that node is. But for more comprehensive documentation, it can be found here, like AI networks, convolution 2D. So this is reference documentation, more detailed reference documentation about that node. What's the concept behind it? What is it doing? What are the attributes? What does each attribute mean? And what does it do? So each node has very comprehensive information associated with it. Like the training node, that's under training, control, train. So what is the training node? How does it work? What do the attributes do? What do they control? So this is a API reference documentation for each node in the system. And as we add nodes, of course, to the system, this will be expanding over time. Examples, remember we said before we currently have 5 examples, and again, this is another thing, we're going to be adding more and more examples over time. Currently we have 5 examples, and this talks about what the example is, what it's doing, what's the data, how does it work, what does each section of the graph do. That's found here in the example section. Experiments are kind of like suggested students' experiments. If you're just getting started, you don't know where to start, you can go here. Here's some 3 experiments that you can do for regression, 3 classify experiments you might want to do, 3 image-based experiments you might want to do. A lot of these these experiments, you take an example, you look at it, you try some experimentation, you modify it, and that's what a lot of these experiments currently involve. But as a student or a teacher, you might want to start here to start learning about AI and what is a model, how does it work, and some of the details of AI. For teachers, there's a quick little section for teachers if you want to learn about how you could use this in the classroom and how to structure it around for either coursework or independent exploration or however you want to use it in the classroom. And of course, there's a quick little frequently asked questions section here at the bottom. So it's a very comprehensive documentation section and tells you exactly how to use the platform as much as we can about what everything is and what it does and how to use it effectively. So that's it for our quick tour of the Digital AI Studio platform, its workspace, documentation, everything involved with it. Like I said, we didn't go into any detail about AI models or the examples. That's going to be the topic of subsequent tutorials. So please look for those walkthrough tutorials coming up soon. But hopefully you enjoy the platform and can use it effectively and learn about AI concepts by building your own AI models and train them and using them. And good luck with the platform. And if you have any questions, feel free to contact us through the feedback dialog or through a direct email. Thank you.